Our next video is going to talk about congruent triangles, but first let's continue something we did on Friday in class. We talked about the triangle inequality theorem. So what if we had a question like this, where if the measures of two sides of a triangle are 3 feet and 7 feet, which is the least possible whole number for the third side? Well, first let's go ahead and draw our triangle. So here's our triangle. We have 3 feet, 7 feet, and we'll call our missing side x. So remember, this triangle inequality theorem tells us that the first two sides have to be greater than the third side. So in order to find this, we're going to end up with three inequalities. So we'll have 3 plus 7 has to be greater than x. 3 plus x has to be greater than 7. And 7 plus x has to be greater than 3. So now we'll just solve for x in each inequality. So over here we have 10 is greater than x, or x is less than 10. We've got x is greater than 4, and x is greater than negative 4. So we already know we have our max of 10, because x has to be less than 10. But then we're stuck with two inequalities that are greater than. So we know x is greater than 4 and x is greater than negative 4. But if we look at those two inequalities, we can tell that x is greater than 4 fits that inequality, and the x is greater than negative 4 because 4 is greater than negative 4. So we can kind of narrow this down to our x is greater than 4. So we know that x has to be greater than 4 but less than 10, and we want to know the least possible whole number. So 3's out because that's less than 4. 4's out because that's equal to 4. 5 would work, and then 10 would not work because it's not less than 10. It's equal to 10. So our answer for this would be 5 feet. So that's how we could find kind of a range of where our third and last side should be. Okay, so now let's go into congruent triangles. So first let's talk about what congruent means. When two geometric figures have exactly the same shape and size, then we know they're congruent. So if we look at this first set, we have three shapes here. They're the same shape and they're the same size. So these shapes are congruent. Alright, if we look at the next set, oops, I had to get out of the pen. If we look at the next set, these are the same shape, but they're different sizes. So those are not congruent. Alright, so 1, 2, and 3 are congruent, and 4, 5, and 6 are not congruent. Alright, let's talk about congruent polygons. If two polygons are congruent, if and only if their corresponding parts are congruent. So two polygons are congruent if and only if their corresponding parts are congruent. The corresponding parts it's referring to is talking about their sides and their angles. So if the sides are the same length and their angles are the same measure, then the polygons are congruent. And real quick, let's talk about this if and only if. Alright, you might see it written out as if and only if, or you might see it written as IFF. Alright, those two mean the same thing. This is just kind of shorthand for it. And that just means that the conditional and the converse are both true. So we talked in class Friday about the Pythagorean theorem and the converse to the Pythagorean theorem. So this is, in this case, the Pythagorean theorem was our conditional, and the converse was obviously the converse. So if and only if means the conditional and the converse are both true. Alright, so corresponding parts of congruent triangles are congruent. Alright, this is very important to know. If all the corresponding parts are congruent, then the triangles are congruent. And then congruent triangles have congruent corresponding parts. So you'll see this written as CPCTC. That's just a short way of saying it so you don't have this long tongue-tying sentence to say. Okay, so this is something that we'll use a lot to do proofs and to show that triangles are congruent and to find missing angles. So let's do an example. Show that the polygons are congruent by identifying all the congruent and corresponding parts, then write a congruent statement. Alright, so we're just going to look and see what's congruent. Well, even though they're kind of turned different orientations, we see that each triangle has the 1 dash, 2 dashes, and 3 dashes, the 1 curve, the 2 curves, and the 3 curves. And so if we kind of imagine twisting this bottom triangle, to where it's the same shape, we kind of have that same shape, we can see that it's going to line up. So if we were to imagine lining our triangles up, we can see that we'd have matching and corresponding sides and angles. So if we're going to write down the corresponding angles, we can see they kind of color-coded it for us. We can see that angle A is congruent. Remember, we have the equal sign with a little squiggly on top for congruent. So angle A is congruent to angle H. Then we have angle B is congruent to angle J. And angle C is congruent to angle K. All right, we can also see our sides. We can follow those with our dashes. Right? So if we have the one dash, we can see that side AB is congruent to side HJ. We can see that side AC is congruent to side HK. Then we can see that side BC is congruent to side JK. And then all it wants for a congruent statement is just for us to say what's congruent. So now that we've lined everything up, so we can just put it all in writing, say triangle ABC is congruent to our other triangle. Now what's important is to make sure you line up your corresponding angles. So since we said ABC, we need to line up our other triangle with the corresponding angles that are congruent. So we start with the one that's congruent to angle A, which was H. Then the one that's congruent to angle B, which is J. And the one congruent to angle C, which is K. So our congruent statement is just triangle ABC is congruent to triangle HJK. So now let's look at another example. It's a different type. Note we're given that triangle ABC is congruent to triangle DFE, and we want to find the values of x and y. So it tells us the the orientation that we should look at the congruency. So we have ABC and DFE. So that tells us right off the bat that angle B is congruent to angle F. Oops, forgot the angle. Angle B is congruent to angle F. Alright, so then we know that 99 equals 8y minus 5. So if we add 5, we get 104 equals 8y. And then we can divide by 8, and we get y equals 13. So there's one variable. Looking at our triangles, and given that ABC is congruent to DFE, we know that the side BC is congruent to side FE. So then we can take our 38.4 and set it equal to 2y plus x. And since we already found y, we can plug in. So we get 38.4 equals 2 times 13 plus x. So that is 38.4 equals 26 plus x. So then you get x equals 12.4. So there's our x and there's our y. So now let's look at another theorem. The third angles theorem says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. And that's supposed to be an S at the end of here. The third angles of the triangles are congruent. So if you kind of think about what that's saying if you have two congruent angles and two triangles, then the third angle's got to be congruent. And that's because if they both have to add up to 180, And so we have angles B and C are going to add to the same thing as angles J and K, which means if you subtract them from 180, then angles A and L are also going to be the same. And last but not least, we're going to look at the properties of triangle congruence. There's three different properties: the reflexive property, the symmetric property, and the transitive property. And all that's saying is the reflexive property is that triangle ABC is congruent to itself. The symmetric property is saying that if triangle ABC is congruent to triangle EFG, then triangle EFG is congruent to triangle ABC, which is backwards. And the transitive property is that if triangle ABC is congruent to triangle EFG, and EFG is congruent to JKL, then ABC is congruent to JKL. This is just three different properties. They're kind of self-explanatory. Looking at the pictures, you can kind of figure out what they mean. And that's it. See you on Monday.